now let's review Amazon Elastic Compute Cloud, or EC2. With Amazon EC2, we gain access to virtual machines. We call them instances. And we do have our choice of just about any flavor of Linux or Windows that we can imagine. Now, of course, these are powered by either the Zen or the Nitro hypervisor. Amazon is responsible for the implementation and the security of that hypervisor. Up until recently, Zen was the hypervisor for everything, but in late 2017, Amazon did announce support for the Nitro hypervisor, which improves performance very significantly. Bare metal is also available, so if you have particular workloads that could benefit where you need critical performance and you want to get out from underneath perhaps any overhead that might be incurred by the hypervisor, you can gain access to bare metal. Now, AWS gives us sort of a price-fixed menu of these different combinations of CPU, memory, disk, network I/O, and so on. We don't really have the ability to say, I want this much CPU and this much RAM and exactly this much network I/O. Typically, those kinds of things just depend on the instance. A large instance may have 2 cores and 4 gigs of memory, or 2 cores and 8 gigs of memory, and nothing really in between, right? Now, with EC2, we do have the ability to launch a single instance. We can launch 1,000 instances or more, according to our current service limits. Keep in mind that most Amazon services do have their built-in limits, and those are there. Many of them are considered soft limits. Those are there to help prevent runaway resource consumption. So the default EC2 limit per account would be 20 EC2 instances, and if you need to go above that, you simply submit a ticket to Amazon support asking them to raise that limit. Now, there are different billing models to fit our needs. We have on-demand, we have reserved instances, we have the spot market, and we will discuss those in more detail later on. But the different billing models just allow us to approach our usage and tailor the way that we spend money according to how we're actually using those machines. Now, keep in mind that the hourly fee does include the license for the operating system. There are opportunities to bring your own license if you already have them, but for the most part, with most billing options, that hourly fee does include the operating system license. Now, there is what we call the AWS Marketplace, and the Marketplace can offer canned solutions. So if you're looking for a particular type of software to solve a particular kind of problem, you may very well find that in the AWS Marketplace. And the hourly fee for that would generally include not only the compute power and the operating system, but also perhaps an additional hourly fee for the license to the software that comes with that machine. Now, when we take a look at the physical components, when we take a look at all that goes into actually running a machine, there, of course, is the rack, the chassis, the switch, and all of the power and the cooling. Then, of course, we have the CPU, the motherboard, and all of the physical components inside that chassis, the power supply and whatnot. Everything inside of Amazon is powered by Intel Xeon processors. And then, of course, we have the hypervisor, be it Zen or Nitro, depending on which family or generation of EC2 instance we're using. Now, at this point here, this would comprise the physical host, the actual machine the physical machine that we are launching virtual machines on top of. And going back to the cloud value proposition, when we think about the value of the cloud, Amazon is responsible for this physical host. Amazon spent the capital expenditures. Amazon made the capital investment to purchase all that was necessary to get this physical host in place. The data center, the power and cooling, the rack, the chassis, and so on. Amazon maintains that physical host. And so we're taking all of the operational burdens that go into running this physical host, and we're shifting that burden to Amazon. And now, as an organization, we're no longer responsible for the physical machine itself. We're no longer responsible for the hypervisor, right? And so when we launch EC2 instances, we can launch those instances, and of course they are powered by that physical host. And now as a customer, as an organization, we are responsible for less. We're responsible for that instance, for that operating system and the application that runs on it. And so we can launch numerous instances. One physical host may power numerous instances. In a typical EC2 usage, there may very well be different customers on one physical host. This is the standard multi-tenant environment that we see in EC2. Now, if you have a need, be it some type of regulatory need or a business policy need to run in a single tenant environment, we can do that as well. So we do have an opportunity to run what we call a dedicated instance. So when we run a dedicated instance, that Amazon will ensure that that virtual machine is placed on a host where we, as an organization, are the only customer on that machine. Now, we can also run what we call dedicated hosts. AWS also gives us that ability to fully dedicate an entire physical host to us so that we can bring applications where our licensing may be tied to the physical machine, to core counts and physical IDs and what have you. Now, every EC2 instance begins with the Amazon machine image, or the AMI. The AMI is essentially a bit-for-bit copy of the root volume. It contains the operating system, be it Windows, Linux, FreeBSD, what have you. It also contains any software that was installed or any kinds of configurations that were done. It essentially represents the state of that machine at the time the image was created. And we can find the Amazon machine image in a number of places. We can find them that are provided by AWS directly. We can find them from trusted publishers such as Microsoft, Debian, Canonical for Ubuntu, Red Hat for Red Hat Linux, and so on. There's also the community AMIs. Other Amazon users out there, developers and other engineers, may create their own machine images, complete with their own software packages and configured in a particular way, and then they make those images publicly available to the community. And then, of course, like I mentioned earlier, there's the AWS Marketplace where we can find canned solutions that may include an additional hourly fee. So to launch an EC2 instance, it's a simple process. We simply choose the Amazon machine image according to the needs of that particular application, choosing the right operating system and any other software that may have been installed. We then use that to launch an EC2 instance. And from there, we can either go on to run our application, or we can choose to then install additional software. We can configure that particular machine, adding users, adding groups, whatever. And then, of course, we can create our own private Amazon machine image from that machine. And from that private AMI, we can then launch clones of that. And whether we launch 1 or 1,000, they will all come out into the same known state. So some use cases for EC2 would be enterprise applications. We might choose to run web servers and web applications, regardless of the language that they're written in: Java, PHP, Node.js, Ruby, Python, and so on. We could run relational databases or even NoSQL data stores on EC2 as well. Now, it's important to keep in mind that when we do run these kinds of things, that we as customers are responsible for them. Whatever we do on EC2, from the operating system through the application and the data, the management of that, the patching and the updating and the backups, that is all our responsibility. And we'll talk more about that in detail as the course progresses. We might decide to use EC2 to do other types of work like video transcoding. We might do batch processing or container orchestration, right? Things like Docker and other container technologies are more and more popular these days, and I've had quite a bit of success with that, running high volume web APIs, deploying them with containers. We may decide to run our own private code repositories on EC2 or use EC2 as build servers. Think things like Jenkins, right? So you can run something like Jenkins or Jenkins build slaves on EC2 as well. So when we think about using EC2, there are a number of best practices that we should keep in mind. And that would be, one, we should treat these machines as disposable. They are disposable. They are ultimately transient machines. Amazon architecture says that we should design for failure, right? We're assuming that everything will fail, and that's how we that's how we go about creating an application that is ultimately very reliable, is by embracing failure. And so keep in mind that machines could go away at any time for just about any reason. It could be that there's a problem with the underlying physical host. It could be that it was accidentally terminated. It could be a runaway script. A bug in our automation caused that machine to be terminated when it shouldn't have. If we're leveraging autoscaling may have chosen to remove that machine because of input from other locations, right? So treat them as disposable. The machine could go away, and our application should handle that. The failure of that machine or the termination of that machine should be handled gracefully. Another practice that's very common within the world of Amazon Web Services is to treat our infrastructures as immutable. That is to say that once a machine is launched, if a machine is launched as doing a particular job, such as a web server, then it's not changed. That starting with the machine image and other automation tools, we can get that machine up into a known state, and it stays in that state. We don't shell into the machine and change it. If we need it to change, we go back to the machine image, back to our source of automation, make the change there, and then replace the machine. Again, so we should, because of the on-demand, pay-as-you-go nature of EC2, we have the freedom to throw things away when we no longer need them. We have the freedom to replace machines very easily. Instead of treating these machines like pets and spending a lot of time and money and effort keeping that machine alive in order to keep the application running, we can simply throw the machine away and replace it with an entirely new one that comes up into the new state that's necessary, right? Another good practice is to treat our logs as streams. So instead of shelling in and manually tailing logs, instead of shelling in and trying to rely on log rotation, in those kinds of situations, I've had this happen to me and I've seen it happen to others, logs sometimes get lost, right? If the machine goes away and it takes the logs with it, now you have a lot of very valuable data that is no longer accessible. So instead of leaving the logs on the machine and relying on some type of remote access to get to them, we can have those logs streamed to other services that we'll talk about later. We should also leverage roles, and we will talk more about this in detail later as well, but roles allow us to control the permissions that machine has when it comes to accessing other Amazon services like S3 or DynamoDB or what have you. We should also leverage automatic deployments. We should automate all of our processes as much as possible. Again, automation is going to allow us to be more efficient in our processes and more secure. And then, of course, we should monitor our EC2 instances with CloudWatch. CloudWatch collects metrics from these EC2 instances and allows us to see just how this instance is being used. Monitoring allows us then to auto-scale. It allows us to determine whether we're getting the value out of our money. It could be that we're spending a lot of money on a machine that we don't actually need because it's perhaps over-provisioned. Monitoring might tell us that it's under-provisioned, right? And then lastly, we should enable scaling and self-healing with auto-scaling. Now, not every architecture necessarily needs that, but many architectures can benefit from auto-scaling. Auto-scaling doesn't necessarily mean that we're expanding and scaling to meet demand, but in some cases, auto-scaling simply maintains a fixed number of machines. Auto-scaling can replace a machine when it's determined to be unhealthy. All right, so going back to our original example architecture, in this architecture, EC2 is giving us that cost-effective, on-demand compute power, getting EC2 instances when we need them in order to satisfy the needs of our application. Private Amazon machine images are giving us a more efficient automation by allowing us to begin with a preloaded software, beginning with a machine that already has most, if not all, that we need to get that machine in place and doing what it's supposed to do. And keep in mind that applications should handle failures gracefully. These machines, again, may very well come and go. They could fail, they could scale out and scale back in, the machine might terminate and get replaced, and so our application is essentially riding atop an infrastructure that is ultimately transient. And so part of Amazon architecture says that we embrace failure, we design for failure, right? And in doing so, leveraging all of these tools, this is how we can build a very reliable, resilient system in Amazon Web Services.